We're going to talk about imaginary and complex numbers. So again, make sure you grab your binders and let's go ahead and get started. So what if we were to come across a quadratic equation written as such? Our first initial instinct would be to solve for x. So if I subtracted 10 from both sides, I'd be left with x squared equals a negative 10. Now we all know to get rid of that power of 2, I got to take the square root of both sides. If I take the square root of both sides, I'd be left with x equals the square root of a negative number. And up until this point in our math career, we've learned that if we have a negative number under the square root, that we think it's no solution. So let's go and discover what we'll do now with a negative square root. So this man, even his calculator does not understand that negative square roots. So he develops a plan. He invents a new sort of number system and new types of numbers. So the imaginary numbers, so this is a whole new number set, were born. Okay, so this name is Descartes. We can thank Descartes for imaginary numbers. So what even is an imaginary number? An imaginary number is an I. So we write imaginary numbers with this lowercase I. And the lowercase I just means the square root of a negative 1. So if we think about the square root of a negative 1, if I square both sides, I would get I squared equals negative 1 because the square would get rid of that square root and we'd be left with just a negative 1. So when we're going through these problems, we're going to work with these different properties, and we know that I is just equal to the square root of negative 1. So how can we use this information to help us solve different square roots? So if we look at the examples, the square root of a negative 25, well, first off, we can see that we have the square root, or we have a negative sign under the square root, and we can't have that. So we want to think about trying to break up the square root. So now, since I know that I equals the square root of a negative 1, I want to see if I can somehow take out a negative 1. So I'm going to split this up into the square root of negative 1 times the square root of 25. So now we know that the square root of negative 1 is I times, and what would be the square root of 25? Square root of 25 would be 5. So this is going to simplify to 5i. We put I in the back so it doesn't look so confusing. It's kind of like a variable, but we know that I is equal to that square root of negative 1. So let's try the next one. If we look at the next one, we have the square root of a negative 6. Again, we see that negative and that red flag should be going off. I got to pull out that negative 1. So I'm going to pull out that negative 1, keep it under the square root. I'm going to multiply by the square root of 6. So then as I go forward, I know that the square root of negative 1 is I times, do we know what the square root of 6 is? We don't. So then we got to think, can I break 6 down into a perfect square? Is there a perfect square that goes into 6? We don't have one, so we will leave it as the square root of 6. So the way we would write this final answer is I times the square root of 6. And this time, I is in the front, because if we put I in the back, it might look like it's under the square root, and we don't want that. So we'd keep that I out front here. So this next one, I'm going to change to orange. This next one, again, let's look inside. We have that negative. So initially, that red flag should be going off. We want to keep that negative. We want to get that negative out there. And I can do so by involving imaginary numbers. So if I take that negative out, I'd be negative 1 times the square root of 40. So now we got to think of the number 40. Can you think of breaking down 40 into two smaller square roots that still multiply together to give you 40? And one would be a perfect square. So if we think about our perfect squares, 1, 4, 9, 16, 25, and etc. etc. Remember, you have to memorize those. So if we think about that, well, we see that 40 is divisible by 4. So I'm going to break this into the square root of 4 and the square root of 10, because if I multiply these back together, I would get back to the square root of 40. So now if I bring this over, we know that the square root of a negative 1 is I. We're multiplying that now by the square root of 4, but we know the square root of 4 is 2, and then I still have the square root of 10. Do we know what the square root of 10 is? Can I break it down any further? I can't break it down any further. We don't know what the square root of 10 is, so I would leave it as the square root of 10. So here I've broken down my radical as much as I can. So my final answer would be written as 2i square roots of 10. Number out front, again, we're going to just kind of ignore it. We're going to
break down the radical underneath first, and we'll come back to the 5 in the front. So we want to break down negative root 48. Okay, so again, we're going to break it down like our tree. Okay, so we're going to get the negative has to be its own, right? Then we still have the square root of 48. And now we want to think about those numbers. What numbers go into 48? Okay, so the first number I think of might be 4. We could do 4. Is there a bigger number? You could try a bigger number, but we'll just stick with 4. So this is going to turn into the square root of 4 and the square root of 12. Now 4 is perfect, so that's going to turn into a 2. Okay, remember the square root of negative 1, that turns into our I. And then 12 again, so 12 we have to break down again because there's a perfect square that goes into it, which would be again that 4, and times 3 would give me the 12 I'm looking for. So here we have square root of 4 turns into 2. 3 doesn't break down any further, so we finally leave it as the square root of 3. So now we have this I on the outside, a 2, and a 2. And again, because there's no operation we see between, oh, don't forget about the 5 in the beginning. Since there's no operation, we're going to multiply all of these. So we actually are going to get 5 times I times 2 times 2. And then we have that square root of 3 that's going to hang out in the back. So the I I'm just going to leave, and I'm going to work with the numbers first. So 5 times 2, that would give me a 10. Then we got to multiply that by another 2. So that's going to give me a 20. Now again, we still have that I, so I'm going to write I, and then we have our root 3. So I'm going to bring down that root 3. This would be our final simplified answer. Again, the I has to be there because of the negative. Okay, so let's do one more example with this 24. So we want to break down the square root of 24. Again, we have the square root of a negative 1. We want to pull that out right away because that's going to turn into an I. And then we still have the square root of 24. So how can I break down 24? Again, look through your perfect squares. I wouldn't try like anything bigger than 24, so I would start with maybe 16. 16, 9 doesn't. So then the biggest perfect square that goes into 24 would be 4. And that multiplied by 6 gets me back to 24. So that turns into a 2. 6 doesn't break down any further, so we leave it as the square root of 6. Now remember, everything on the outside we're going to multiply together, and it's going to create one final term. So we're going to put the 2, then the I, and then the square root of 6, because there was nothing else I had to multiply together. So my final answer there would be 2I square root of 6. So again, I want to thank you for taking good notes, and I will see you when I see you.